There is a dry lake bed in the middle of the California desert where rocks move on their own, not slowly in some metaphorical sense. Not because of earthquakes or animals or human interference, they actually slide across flat, cracked, baking mud, some of them weighing hundreds of pounds. And they leave long, clean tracks behind them, stretching across the playa like someone dragged furniture across a warehouse floor in the middle of the night. For nearly 100 years, nobody could explain it. Scientists measured the rocks. They photographed the tracks. They camped nearby and waited. And for almost a century, every single person who studied this place left without seeing a single stone move. The rocks would be in one position when researchers arrived. They would be in a completely different position months later. And no one, not one human being, had ever witnessed the journey in between. You probably think you know what causes it. Most people do. Wind, obviously. This is Death Valley. The wind howls through the mountains. It must just push the rocks across wet mud after rain. That answer feels right. It is tidy, it fits, and it is almost entirely wrong. The real mechanism is far stranger, far more specific, and it only happens during a window of conditions so narrow and so precise that it took researchers over a century to catch it in the act. When Jim Norris, a geologist at the Scripps Institution of Oceanography, and his brother Richard finally installed GPS trackers on the stones in 2011, what they discovered rewrote the entire story of Racetrack Playa. But to understand what they found, you need to understand the place itself first. Racetrack Playa is a dry lake, or playa, sitting at about 3,700 feet of elevation in Death Valley National Park. It is roughly 3 miles long and 1.5 miles wide. The surface is almost perfectly flat, cracked into a mosaic of mud polygons when dry, and occasionally flooded by a thin sheet of water after heavy rain. At the southern end of the playa, there is a rocky hill called the Grandstand. Boulders and rocks tumble off the mountains at the edges of the playa and come to rest on the flat surface below. And then they start moving. The tracks they leave are unlike anything else on Earth. Some go straight, some curve in gentle arcs. Some appear to zigzag or double back on themselves or run parallel to each other as if two rocks made the same trip together side by side without touching. Some trails are only a few feet long. Others stretch for hundreds of feet. The longest documented trail is nearly 860 feet. One rock, nicknamed Karen, traveled more than 820 feet in a single winter. When you stand on the playa and stare at those tracks, the first thing your brain does is reach for a human explanation. Something must have moved this. Someone must have been here. Because nothing in your daily experience tells you that a 700-pound rock slides across flat desert mud on its own. But here is what is actually happening. It starts with rain. Enough rain to flood the playa with a shallow sheet of water, typically a few inches deep. That water sits on the flat surface. Then overnight the temperature drops. And in Death Valley, in winter, it can drop hard and fast. The thin layer of water freezes. Not into thick ice, but into a fragile, transparent sheet, perhaps 3 to 6 millimeters thick, a pane of desert ice covering the entire playa surface. During the day as the sun climbs, that ice sheet begins to melt and crack. It breaks apart into large, floating panels. Now here is the part that no one predicted. Gentle winds, far below the speed anyone had assumed would be necessary to move rocks, push those ice panels across the surface of the still liquid water beneath, and the ice panels, as they move, push the rocks embedded at their edges. The rocks are not being pushed by wind directly. They are being carried by ice, by floating, drifting, nearly invisible sheets of ice that melt completely by mid-morning and leave no trace of themselves behind. By the time a hiker reaches the playa at noon, the sun is bright, the mud is beginning to dry, and there is no ice anywhere, just new tracks, just rocks in positions that are different from yesterday, and zero explanation visible to the naked eye. Richard Norris, in a 2014 paper published in PLOS One, described the moment his team first witnessed the movement. He called it, and this is not an overstatement, one of the most exciting moments of his scientific career. They were watching through binoculars from across the playa. It was December, there was ice, and then quietly, almost lazily, the rocks began to slide. No drama, no noise, just slow, unhurried movement, like something underwater, rocks moving at speeds between 2 and 5 meters per minute, pushed by ice panels in a light wind. The ice does something else the pure wind theory never explained. It explains the tracks that curve. It explains the parallel trails. Because two rocks sitting near each other can be caught in the same panel of ice and pushed together in the same direction, their trails running side by side until the ice breaks and each rock drifts a different way. The curves in the tracks are the curves of the ice panel itself, rotating slowly as it moves, carrying the rock with it. The zigzag trails? Those are multiple events. A rock moves during one ice session, stops, gets frozen into a new panel days or weeks later, and moves again in a slightly different direction. Every mystery the tracks presented had been hiding the same answer. Ice. Thin, temporary, invisible by midday. The most dramatic geological process on the playa leaves no trace of itself by lunchtime. There is something philosophically unsettling about that. Paula Messina, a geologist at San Jose State University who spent years mapping the tracks before the GPS era, once noted that the conditions required for movement were so specific and so brief that the probability of a researcher being present at the exact moment of movement was vanishingly small. Not because movement was rare exactly, but because the window for it opened and closed so quickly that all the evidence destroyed itself before anyone could witness it. Think about what that means for a moment. The rocks had been moving for thousands of years. Every winter, potentially, the conditions aligned. The water flooded the playa. The temperature dropped. The ice formed. The wind nudged it. The rocks slid. And then the sun rose and the ice evaporated and the world went back to looking like a desert, and no one was the wiser. The tracks were the only evidence. And the tracks invited exactly the wrong conclusion. They screamed wind. They implied brute force. They made people look up at the sky and think about gusts and storms, when the real answer was sitting half an inch above the mud, invisible and temporary and gone by morning. This is the thing about Racetrack Playa that nobody talks about. The mystery was never really about the rocks. The mystery was about the limits of human observation, about how confidently we draw conclusions from the evidence we can see, without ever asking what evidence might have vanished before we arrived. Your brain does this constantly. It builds explanations from the traces things leave behind. It reconstructs causes from effects. It fills in the gaps with the most familiar, most plausible answer available. Usually this works. Usually the most visible explanation is the right one. But Racetrack Playa spent a century proving that sometimes the actual mechanism is brief, fragile, and designed by coincidence to erase all evidence of its own existence. The rocks are not magic. They were never magic. But the process that moves them is, in its own way, more astonishing than magic, because magic is invented. What happens on that playa is real, and it happened on its own. In the dark, in winter, while everyone was somewhere else. There is a dry lake bed in the middle of the California desert where rocks move on their own. And now that you know how, the tracks look different. Not like a mystery waiting to be solved. Like a message from a process so subtle, it could only speak in the language of absence.